Friends, welcome to another class of statistics. In this class, we will discuss about mode and median. So let's start with mode first. Mode of group data. In a given observation, the observation having maximum number frequency is called mode. For example, the mode of the numbers 1, 2, 2, 3, 4, 5, 6, 5, 6, 5, 5, 5, 7, 7, 7, 8 is 5, as 5 is appearing maximum number at times. That means in any given number of observation, the observation having highest number of frequency is called mode of that particular observation. If in a given observation, more than one value has same maximum frequency, then the given data is called multimodal. For example, following are the marks obtained by 72 students in a class test out of 10, that is the total mark in the class test is 10. Find the mode of the given data. So the table is given here. In this table, the table it is clear, that means the out of 10, 3 students scored 1, 5 students scored 2, 12 students scored 3, 18 students scored 4, 23 students scored 6, 8 students scored 7, 2 students scored 8, and 1 student scored 10. That means the maximum number of frequency 6 is having maximum number of frequency. So we can say in this data 6 is the mode. The mode of the given data is 6 as it has the highest frequency, that means 23. Modal class. In a group frequency distribution, the class having maximum frequency is called modal class. For example, that the class interval 0 to 10 having number of students is 2 to 10 to 20, let's 9, 20 to 30 is 14, 30 to 40 is 20, 40 to 50 is 22, and 50 to 60 is 8. That means here 40 to 50, this class is having highest number of frequency, or we can say highest number of students. So we can say 40 to 50 is the modal class. Here the highest frequency is of the class 40 to 50, hence the modal class is 40 to 50. Now, mode of group data. In a group data, the mode is the value that lies in the modal class. That means mode in such cases is given by small l plus f1 minus f0 whole divided by 2f1 minus f0 minus f2 whole into h, where l is the lower limit of the modal class, h is the size of the class interval. That means size of the class interval means upper limit minus lower limit of the class. F1 is the frequency of the modal class, f0 is the frequency of the class preceding the modal class, and f2 is the frequency of the class succeeding the modal class. Let's see an example first. Find the mode of the following frequency distribution. The table is given. The given data maximum frequency is 16 and the given class is 30 to 40. That means the modal class is 30 to 40. So here L is 30 because the lower limit of the modal class 30 to 40, lower limit is 30. H is 40 minus 30, the class interval. So it is 10. H is 16. The frequency of the modal class F1 is the frequency preceding the modal class. Sorry, F0. So F0, we can say F1. F1 is 10, and F2 is the modal class, the succeeding the modal class. That means which is equals to 12. So mode is nothing but L equals to F minus F1 by 2F minus F1 minus F2 whole into H, or put in the values we get. Mode equals to 30 plus 16 minus 10 whole over 2 into 16 minus 10 minus 12 whole into 10, or it is nothing but 30 plus 6 by 10 into 10, which is nothing but 36. Hence, the mode is 36. Here, one more thing I would like to tell you. Here, 36 we got as the mode, and the modal class is 30 to 40. That means 36 lies in between 30 to 40. mode always lies within the model class. Let's see another example. An NGO working for the welfare of patient maintains its record as follows. So here is the record of the NGO. Find the average age of the maximum number of patients. Maximum number of patients means we have to find the mode. In the given table, the maximum frequency is 35 and the corresponding class to the frequency is 20 to 40. Sorry, the maximum frequency is 315 and corresponding class to the frequency is 20 to 40. So the model class is 20 to 40. That means we can say L equals to 20, F1 equals to 315, F0 equals to 120, 120, and H equals to 20. Now putting into the value, and so we know mode equals to L plus F1 minus F0 whole divided by 2F1 minus F0 minus F2 whole into H. Or putting the values we get, it is 20 plus 315 minus 35 whole divided by 2 into 315 minus 35 minus 120 whole into 20, or it is nothing but 20 plus 280 by 475 whole into 20, which is nothing but 31.79. Hence, the average age of the maximum number of patients is 31.79. If the mode of the following series is 39, find the value of f. So here in this question, the mode is given, but one frequency of a particular class is missing. We have to find out that particular frequency. Given that the mode is 39 and it lies between 35 to 40. As I said, the mode always lies within model class. These are the model classes. But it is already given that mode is 39. That means the number 39 lies between 35 to 45. So the model class is 35 to 45. What we can say, L equals to 35, H equals to 45 minus 35. That means the class interval, which equals to 10. F1 equals to 7. F0 we can treat it as to be equals to F, and F2 equals to 4. Now we know mode equals to L equals to F1 minus F0 whole divided by 2F1 minus F0 minus F2 whole into H. Or putting the values, we can write 39 equals to 35 plus 7 minus F whole divided by 2 into 7 minus F minus 4 whole into 10. Or on simplifying, we get 4 into 10 minus F equals to 10 into 7 minus F, or it is nothing but 40 minus 4 equals to 70 minus 10F, or 6F equals to 30, or F equals to 5. Hence, the value of F is 5. That means the frequency of the model class is 5, is the answer. Let's come to the median. Median of group data. Median is defined as the middlemost or the central observation when the observations are arranged in either ascending or descending order of their magnitude. So median divides the arranged series into two equal parts. That means 50% of the observation lie below median and the remaining 50% lie above the median. The median of the data depends upon the number of observations. If n, say be the number of observations, and let the observations are arranged in either ascending or descending order, then case 1, if n is odd, median equals to value of the n plus 1 whole divided by 2th observation. And in case 2, if n is even, median equals to mean of the value of n by 2th observation and n by 2 plus 1th observations. Let's see an example. Find the median of the first 10 natural numbers. The first 10 natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means here the total number of observation is 10. So the total number of observation, or you can say n equals to 10. Now, actually, now if n is odd, that means it falls in the second case. When n is even, median is nothing but mean of the n by 2th observation and n by 2 plus 1th observation. So now n by 2th observation is nothing but 10 by 2, which is 5th observation, that means it is 5. And n by 2 plus 1th observation means it is 10 by 2 plus 1, which is 6th observation, that means 6. Now mean of 5 and 6 is nothing but 5 plus 6 divided by 2, which is equals to 5.5. That means the median of the first 10 natural number is 5.5 is the answer. Let's see some more examples. Okay, let's start with cumulative frequency. The frequency of an observation in a data refers to the number of appearances of the observation. That means, or I can say the repetition of the observation in a given data. Cumulative frequency of a class is defined as the sum of all frequencies up to the given class. For example, the set of the data given below shows the age of the participants in a summer camp. Draw the cumulative frequency of the frequency table of the given data. And the table is given here. Let us draw the following table to find the cumulative frequency of the given data. That means here the cumulative frequency for the first 10 and the first number is 3. For the second number is the first observation plus that of second one, which is 18 plus 3, that's 21. For the third observation, cumulative frequency is nothing but sum total of all the observation, all the frequencies of first, second, and third. And that's 21 plus 13, which is equal to 34. For the fourth one, it is sum total of the frequency from first observation to the fourth observation. So therefore, till third observation cumulative frequency is 34. The cumulative frequency of the fourth one is 34 plus 12, which is 46, and so on. Note, the cumulative frequency of the first observation in any given data is the same as the frequency of that particular data. Second one, the cumulative frequency distribution is of two types, either less than type or more than type. Let's see through an example. Consider a group frequency distribution marks obtained by 15 students in a class test of out of 50. Find the cumulative frequency distribution of less than type and more than type. Cumulative frequency distribution of less than type, and here we have to verify the number of students who score less than 10. Less than 10 here in the given table, the number of students who scored less than 10 is 3. The number of students who scored less than 20 is nothing but 3 plus 10, because the students who scored 10 or less, they also scored less than 20. So it's 3 plus 10. Now number of students who scored less than 30 is nothing but number of students who scored less than 20 plus number of students who scored less than 10. That means sum total of all these three. So the frequency distribution of less than type can be written as follows. That means for less than 10 it is 3, less than 20 is 10 plus 3, which is 13, less than 30 is 13 plus 18 equals to 31, less than 40 it is 21 plus 15, which is equals to 46, less than 50 it is 46 plus 5, which is equals to 51. That means whenever we are considering the frequency distribution of less than type, we have to consider the upper limit of the class interval. To find the cumulative frequency distribution of less than type, we have to take the upper limit of the class interval into consideration. Now come to the more than type. Cumulative frequency distribution of more than type. In this case, we have to find out the number of students who score more than 0, that means which is 51. Students who score more than 10 is 15 minus 3 is 48, and so on. So the frequency distribution table can be given as follows. There are more than 10, more than 0 means all the students, so it is 51. More than 10 means the students who scored either 10 or less than 10, which is nothing but 3, so it is 15 minus 3, 48. More than 20, that's the students who scored either 20 or less than 20, which is nothing but 48 minus 10, so 38, and more than 30 is 38 minus 18. It is 20, and more than 45. It is 20 minus 15 is equals to 5. To find cumulative frequency distribution of more than time, we have to take the lower limit of the class interval into consideration. See here 0, 10, 20, 30, 40. These are nothing but the lower limit of the class interval. But whereas for finding the frequency distribution of less than time, we consider the upper limit of the class interval. Friends, this was for today's class. We'll discuss some more about median along with some examples in the next class. In the meantime, you keep practicing more and more such questions, and in case you come across any difficult question, do share your question with me. It will be a pleasure for me if I can help you out in solving your doubts, solving your questions. So this was for today's class. Thank you.